Okay, guys, it's time for our monthly members meeting. So we're going to go ahead and kick it off. This is the agenda for this evening. We'll do the welcome and introductions. We have book of the month, events and outreach notes. We have some Alcor news this evening. And then we have our main speaker, David Teskek, who's going to talk about why the moon. I should have put a question mark at the end of that, but why the moon? Then Wayne is going to do a What's Up in Space segment for us. I'll have a couple slides for the shallow skies. We'll transfer the SeeStar, and we'll wrap up with some very nice astro photos from our members. Just as a teaser, the Leo triplet and Bode's Galaxy M81 were the main things that everyone has been imaging the last few weeks. So that's our agenda for this evening. Okay, the first thing that we like to do is to see if there are any new members and welcome you, see what's going on. Yes, sir.
Hi, my name is Derek Eve. I was actually a member here several decades ago.
Oh, wow, okay.
With my young son having an interest in it then. So he's grown up and moved away, and so I thought I'd come back and rekindle my interest a bit.
That's great, Derek. Welcome. Glad you could make it this evening. Do you have any particular interest or instruments or?
I have no instruments. I have some stabilizing binoculars and a star chair, and I think that's where I'm going to start.
And when I do shallow skies tonight, you'll see that that is a good starting point. So that's great. Excellent. Welcome. Anyone else new? Yes, sir.
My name's Les Lorenz, and I've been like you. I've been a member in the past. Never came to a meeting outside of the area.
Okay.
And now I finally got a couple of telescopes that are worthy of using as a telescope, and so I became.
Well, they always say that the best telescope is the one that you use. So as long as you've got one that you're using, that's great.
Certainly nothing wrong with binoculars.
No, binoculars are a great intro to astronomy. Well, welcome. Glad you're here with us. Anyone else in the room?
Do you want me to turn off those lights?
Turn off the backlight, perhaps?
Are these the switches?
Yes, they're one that's,
You gonna try?
no,
No.
no, one more. No, last one. There you go.
Yay.
All right.
Sure, take that.
Anybody online currently new and visiting us?
Hi, my name's Cheyenne Brem. I'm actually here from the Master Naturalist class that was just held at the Robinson Nature Center. They suggested that I attend this.
Okay.
I'm not a member. I may have misunderstood.
So you're not a member, that's fine. We are always happy to have visitors come and drop by. And so what was it that you were doing at the Robinson Nature Center, you said?
It's the Master Naturalist program that
Okay.
UMD sponsors. So Robinson Nature Center holds a yearly training.
Very good. Well, we're glad you're with us this evening. I hope you'll find it interesting.
Oh, thank you.
Jim,
Yes.
start recording it.
Yes, I did. Okay, I know I started. Okay, anyone else online? All right. So we always have a book of the month. So David, our librarian, would you like to tell us about your choice for this month? Come up.
Well, one of the things I noticed looking through the library is anything from Sten Odenwald, kind of one of those the astronomers out there that likes to work with the general public and explain anything and everything along with like Phil Plate. So actually have to have a copy of my own library at work. So again, slightly dated, but some of the answers to the questions haven't changed over the years, and who knows, you may find out some answers to the question maybe you've always wondered, one of those things that always wanted to ask but were afraid to, but really good in terms of just a lot of general knowledge, astronomy things in here. So they might be good additions to, add to our library as it is, so. Definitely recommend.
I think. Alrighty. And also for those of you that may be new or may not know, HAL does have a very extensive library from which you can borrow books. It is housed at our observatory out at Alpha Ridge Park. And online, I believe that there's actually an inventory, a listing of all the books. So it is really quite extensive. And if you're looking for a particular, if you're interested in solar or planetary or deep sky or astrophysics, there are lots of books there that you can talk to Dave. He can arrange for you to check them out and you can read them. Okay. Wish I could get rid of this thing.
Are you coming down?
That's what I get up.
Oh.
There we go. Finally. All right, so let's talk a little bit about some of the HAL outreach items. We've had a very, very active last 30 days. So Jose, how are things going in that regard?
Oh, April was, it had a lot of events. We had the April 11 members start party. 16 people were there with telescopes. That was a lot of fun. Then what was the next one? April 19th, 4 members came in. That was an impromptu, if I'm not mistaken. And April 12th, excellent transparency. Yeah, it's been just a lot of impromptu events happening in April. And now in May, we're just waiting for the next clear night so we can have more.
Well, and actually this Saturday, you've got an event, don't we? This Saturday is the members star party?
I don't think so.
No?
Let me double check.
I know we've got a new moon coming up,
May
so-
16th, yeah, you're right. May
I
16th.
was gonna say, if
is
we're
the
gonna
next.
miss the new moon, we're gonna lose our license for being an astronomy club. All right, so, and then there's another public one, the 23rd. Hopefully we'll have clear skies and, obviously we encourage members to bring their scopes out because you certainly have the halo operating, which always is a big draw, but invariably there are a lot of people that enjoy being able to put your eye to an eyepiece and to see the moon or to see Jupiter's satellites or a star cluster. I think there's something almost like visceral about that, as opposed to looking at something up on a flat screen. So, I'm not knocking the observatory in any way, but it really is helpful when we have members that also bring out a wide range of scopes, because it also allows people to see, oh, well, this is what you can see with a small scope, or this is what you can see with a large scope. So I definitely encourage you guys, if you're free on the 23rd and skies are halfway decent, come out and help support us with our outreach efforts. All right, and then we have the external outreach events. And you can see Jose here. We had a very successful event at the Clarksville Commons Earth Day. Mike Miller, are you happen to be on this evening? Okay, I guess not. Mike is our coordinator for outreach events. So things that HAL is not sponsoring, but which HAL has been participating, has been invited to participate and has been able to participate. So how did that event go? I know you said you had a great solar image because you had just gotten your solar scope working, or?
Oh, that's the Coronado I got as a donation last time. I got a really nice solar image. I don't know if we're gonna have it at some point in the slides, but that was really fun. We had like over 25 people like going there like throughout all the time. Like kind of a lot of people just going there, sometimes kids with their families. We had a telescope with a wide light filter, and we had the Coronado at the same time, and a SeeStar as well. And we had a table with the solar system as well.
Oh,
So
great.
it was a lot of fun.
So Bob came and did his solar system.
Mhm.
That's perfect. Great. So it sounds like that was a very successful event, and I think we have been going and supporting their Earth Day for quite a few years. So another sunny day there, and it worked out well. So that was great. I will mention that we are still looking for potentially a couple more HAL members to participate in the fall, September 26th. There is the Astronomy Festival on the National Mall, and I know that we have participated the last 2 years. The logistics are such that it may seem intimidating of, oh, how am I going to get a telescope on the mall? But they actually have it pretty well organized. Now, the one caveat that I will put out here is that this may be in flux. I think the organizer unfortunately passed away last month. So and I haven't heard anything. I don't know if there's somebody ready to step into his shoes to continue with this effort. I hope so, because it was really an excellent outreach effort. Lots of people coming by the mall and looking through telescopes and whatnot. So if that potentially interests you in helping to man a table for HAL, to tell people about HAL, as well as maybe bring your telescope, I definitely would suggest reaching out to outreach@howardastro.org. That's the email address where all outreach events, not the sort of things that Jose handles, like internal Alpha Ridge star parties and whatnot, but for outreach events, that's the email address to use to get in touch with Mike. Okay, and we have some Alcor news here this evening. So, Aldous, are you on this evening?
I'm here.
Oh, you're here. Excellent.
Yeah.
In the dark, I couldn't see you.
So I'm Aldous and I'm your Al for you new guys. I'm the liaison to the Astronomical League, which is the Astronomical League is like the largest federation of all astronomy clubs in the nation. And you're part of it through your membership in HAL. And the big news is they're having their national conference coming up in Cincinnati. You can make it August. I think it's August 12th through the 15th. You can see there. And what else? It's the 80th anniversary of this AL, the Astronomical League. I think they started right after WW2, sometime in the 40s. So anyway, so you should be getting every month from me these stargazing graphics, the highlights for the month. And also you should be getting this great magazine, Reflector, from AL. This had an article from one of our members in a young man that's a sophomore in high school here, Sundar. And there's also an ad right there about the convention coming up. So that's it.
That's all right. And the AL is a great resource. Again, if you're new or if you know about it, they have wonderful observing programs, things that are, kind of like a laundry list of things to, hey, go find this and, put it into a log entry. And that can be a really great way to get started to knowing the sky. They have binocular lists. I think they have some naked eye lists as well. So there's all sorts of, I did the one on Jupiter, I think about a year ago. And, I think I know Jupiter pretty well, but, I learned something by taking that particular program. So, and hopefully I'll just maybe on subsequent meetings, we'll have you maybe highlight one or two of their programs that are popular so people can be aware of them. But again, I think that that's an excellent way if you want to get to know the night sky, or maybe you want to get to know the moon. They've got programs in terms of identifying lunar features. It's a great way to kind of increase your understanding and your skills by completing one of their programs. And being a member of HAL, you are automatically a member of the Astronomical League.
What do you get when you complete one?
It depends. Sometimes you get a certificate, sometimes you get a pin. Sometimes I don't think you get much of anything except the bragging rights. You always get published in the Reflector Journal that you completed that particular program. And I think there is a database where you can go and look up online and, hey, gee, back in 1980, Tomney completed his Messier list, So it's you get bragging rights more than anything else, I guess. But more than that, you really do get a better understanding of whatever it was that you started out on that program. All right, so we're going to come to our feature presentation here this evening. And tonight we're fortunate to welcome David Teskek, who is a longtime amateur astronomer with deep expertise in both lunar and solar astronomy. David has shared that passion widely through the decades of public outreach. He has served as Assistant Planetarium Director at the Allworth Planetarium in Duluth, Minnesota, and later on as Assistant Director at the Davis Planetarium in Jackson, Mississippi. He has presented countless astronomy programs at the Rainwater Observatory, nature centers, and schools, and they always have the goal of making the sky accessible to everybody. Before retiring, David was an award-winning science teacher recognized repeatedly for excellence in the classroom. He is a two-time STAR teacher, a Teacher of the Year award from the Parents for Public Schools organization. Now, where was I? All right. So before retiring, David was an award-winning science teacher recognized repeatedly for excellence in the classroom. As I mentioned, he's a two-time STAR teacher, Teacher of the Year from the Parents for Public Schools organization, and he's received honors from both NASA and the Air Force Association. NASA recognized his work on Mission Home, connecting space science to real-world applications, and the Air Force Association named him the Krista McAuliffe Teacher of the Year for his outstanding teaching of air and space sciences. So today, David continues to serve the amateur astronomer community as the coordinator of the Lunar Topographical Studies program for the ALPO, the Association of Lunar and Planetary Observers, where he helps observers around the world deepen their understanding of the moon's complex and beautiful landscape, as well as publishing their monthly newsletter, the Lunar Observer. So please join me in welcoming David here this evening as our speaker. David, I'm going to stop my share and then hopefully you can share your screen. David is not muted.
Let's see, where do I find? Oh man, we really practiced this the other day.
At the bottom is the share control usually in Zoom. Bottom center.
Oh, be patient with me.
If you drag your mouse to the bottom of your Zoom screen, it may be hidden and that might cause it to pop up.
Oh, I have the share. I'm just
Okay.
trying to, and I go to window and I see your picture here of the audience. I'm trying to figure out how do I get to my PowerPoint.
If you do share the whole thing in the upper left-hand side usually, and then you can launch your PowerPoint.
Can you see that?
Give it a second. Let's see.
Oh, there it is. I got it.
All right, something's coming through. There we go. Now we see your perfect. Now we're in business.
We got it.
Got it.
Hey, that took less time than I thought. Well, Jim, thanks so much for having me do this presentation for HAL. I look forward to it. When Jim contacted me, he said something about studying the moon. Why do we study the moon and what are the reasons for it? And it's a great subject, a great idea to talk about. And it sounds like just from a little bit of talking I see here with HAL, we have all sorts of interest levels. I think the moon is a great place for you to start. Again, I'm David Teskek. I've been the Lunar Topographic Coordinator for the Association of Lunar and Planetary Observers for 7 years, which I kind of find hard to believe myself too. I have a long, long history of astronomy. I've made daily drawings of sunspots since back in the late 70s. I now have more than 10,500 daily solar drawings, and lately I'm imaging in hydrogen alpha, so it's great fun to look at the sun. I've always been an observer of the sun and the moon, and plus whatever else that I could catch along the way. So the question is, are you a selenophobe? Like you, I like going out to the observatory on those dark and velvet nights with no moon and little, if any, artificial light and endless stars. But we know that these nights are rare, that allow us to explore those very far-off wonders. And yes, we all would love to observe those wonderful faint fuzzies with our optics, whatever they are. But let's face it, those times are rare. Most of us live in urban areas where the deep sky treasures are very challenging to observe. But instead of just put your telescope away, maybe we should embrace our world on our doorstep. The moon is our closest world. It's bright, it's detailed, it's endlessly challenging. It's visible with binoculars or the smallest of telescopes, and for many of us, it's the first object that hooked us onto astronomy. And of course, the moon is not at all bothered by light pollution and is visible, at least for some of the night, almost every night of the month. So think about that. You're in bright lights. You can still go moon gazing. You can get the public out moon gazing, no problem. Just a little bit of a lunar primer here. The moon is about 2,100 miles across. So if you held up the moon next to the Earth, it's about a quarter the size of the Earth. One great example that I saw before, if you have a basketball in one hand representing the Earth, the moon would be about the size of a tennis ball. If you could pull the moon out of the sky, it would roughly span across the United States. But its mass is small. Its mass is only 1/81st the mass of the Earth. So thus its gravity is only about 16% of that of the Earth. So if you're a 200-pound person, you'd weigh around 32 pounds on the moon. But of course, you'd still have all your mass with you. You'd just weigh less. You'd step on the scale less. And if you go to the moon, you can do the bunny hop like this man is. The moon is our natural satellite. It's around 238,000 miles away. If you're not going to remember that, it's about 250,000 miles away. The moon's orbit is elliptical. Sometimes it's a little closer, sometimes it's a little further from the Earth. And that gives us the term the supermoon, which means it's a full moon that's bigger and brighter than other moons. And it also gives us these pictures by Jim of a annular eclipse when the moon was a little bit further away in its orbit and we had a ring of sunlight around the edge of the moon. And we have a total eclipse on the right where the moon was a tad bit closer and all of the sun's photosphere was blocked out by the moon for a brief period of time. The moon takes about 27.3 days to orbit the Earth. Because of the Earth's revolution around the sun, it takes 29 and a half days between successive full moons. So if we have a month like this May, we have 2 full moons in the same month, it might be called a blue moon. So we had a full moon on the 1st of May or thereabouts. So since May has 31 days, we're going to get another full moon at the end of May. I'm not all that thrilled by the terms blue moon, super moon, all that stuff. In fact, a few years ago, we had a blue moon, a super moon, and I believe a lunar eclipse all at the same time. And NPR even called me to do an interview about it. Hey, it happens. So why do we study the moon today? Judging from our audience, we have some people that may have remembered the Apollo missions that ended a bit more than 50 years ago. The Apollo missions landed 12 astronauts on the moon in the late 1960s and early 1970s. The last manned mission to the moon was in December of 1972 until just a month ago when Artemis 2 sent 4 astronauts around the moon. So Artemis is taking the moon to center stage again. Human missions to the moon are returning after more than 50 years. And with that, we have new landing sites, new science, new partners. You know, it won't all just be NASA, it'll be SpaceX and Blue Origin and all that stuff. And the moon becomes a current destination, not just a relic of the past. We live in interesting times. The United States, of course, is aiming to land astronauts on the moon by 2028 or thereabouts, and the Chinese are aiming to land their astronauts on the moon somewhere around 2030. There's new regions on the moon to explore and new targets with new science. The present focus is on the south pole of the moon around the craters Shackleton, Malapert, and Hawthorne. At the south pole of the moon, there are very extreme shadows, dramatic topography, and very unusual and unique illumination. Some of these craters that you see in this image right here are permanently in shadow. The sun never shines down, excuse me, sir, down at the bottom of these craters. And new spacecraft in the last 15 years and into the future, like the Lunar Reconnaissance Orbiter, Viper, which is a rover, and commercial landers, are making new maps of these features. What's most interesting is in these deep, dark craters, it is assumed that long ago comets hit these craters. They hit everywhere, probably. And comets made of ice, the ice would still be there. So there is a water source there in these craters. And of course, that would be great for the astronauts to not have to carry all that water up there. And that they could use the water for an oxygen source and perhaps for a rocket fuel source, maybe to go even onwards to Mars. Other things that have come up recently about the South Pole being interesting is on the back side of the moon, the far side of the moon, there's a huge, huge crater, the largest crater in the solar system, called the South Pole Aitken Basin. And over 4 billion years ago, a huge asteroid blew out a hole, huge, couple thousand miles across almost, and probably blasted into the mantle of the moon. And it probably blew some of those mantle rocks into the South Polar region. So if that's true, the astronauts will have some very unique specimens to study. For us here on the Earth, the South Pole is visible somewhat. The moon wobbles a little bit. It's called libration. It wobbles sort of like a top, up and down and side to side. So sometimes we can see, say, the South Pole a little better than other times. You can see on these images that I took, especially this one on the right, the South Pole is mighty mountainous. And the idea actually is to land the lander on some of these mountains and go down into the shadowed craters behind the mountains, which at best to me sounds terribly risky, but maybe they'll figure it out in a few years. One thing for sure, no matter how Artemis turns out, it will trigger public interest. And as most of you at the Howard Astronomical League members understand, you understand the importance of outreach. It was great to hear the little talks about the outreach that you did in April. The Artemis mission will only heighten interest in space. But even without it, Artemis, there's no target in the evening sky that will take the breath away from a newcomer to astronomy like the moon through a telescope. And you will get a huge amount of questions, ranging from very basic to quite complex. So why not arm yourself with a little bit of knowledge about our moon? Sorry, the question that will be asked almost every time, at least down here, is can you see the flag? And no, you can't. So let's look at the moon in a bit more detail. We're going to look at the science of the moon, which is selenography. So let's look just a little deeper on an image of the moon like this. When we look at the moon, the line between day and night is called the terminator. It is near the terminator that the shadows of craters, mountains, domes, wrinkle ridges, and everything else stands out. This terminator is right here. It changes probably by the hour, and that's where the details really stand out compared to, say, to the right, far away from the terminator. If you are patient, you can see changes along the terminator in a short amount of time, like these mountain shadows right in here. You'll see them change in 10, 15 minutes if you're patient. The moon has two basic terrains. The Maria, which are large, flat, lava-covered plains. They're fairly dark. And the highlands up here, which are lighter in color, are heavily cratered and stand above the Maria. The Maria are visible to your unaided eye. Those are the things that make the features like the man in the moon. These Maria were likely formed around 4 billion years ago when huge asteroids struck the moon, forming these large circular multi-ring basins. Like this is Mare Nectaris. You can see that here. Here's one ring. Here's an outer ring out here. These are beautiful features to see. And later, a billion years later or so, lava flooded these Maria to various levels. Some, like Mare Nectaris, are about half full. We'll look at some full ones coming up. This is Mare Humarum here in the southwest quadrant of the moon. You see a beautiful mountain ring around it. And of course, beautiful craters and wrinkle ridges here. And the one that really stands out as circular is Mare Crisium in the northeast of the moon. And it is the only really evident Maria that's separate from everyone else. It's surrounded by highlands. We move to a little bit smaller features. Those are the craters. Craters are bowl-shaped depressions, mostly caused by ancient asteroid strikes. The largest craters are nearly 300 miles across. So think of that when telling your audience that how big 300 miles across is for some of those big craters. And craters, of course, cover all of the moon by the many, many, many thousands. We have not seen a naturally formed crater created in the telescopic age. Meaning, say on this photograph right here, we didn't say, hey, that crater wasn't there yesterday. It would be fun if it was, but we haven't really seen one that large get formed. But that doesn't mean they don't get formed. Craters have been formed by rockets hitting the moon that have been identified, like the old Apollo rockets. And meteors do hit the moon. And if you're looking on the dark side of the moon, these impacts show up as star-like points of light for a moment or two or three. Not very long. They're like a star, and they're gone. The Association of Lunar and Planetary Observers has a meteor impact project we'll talk more about coming up. Craters, though, or back to craters, are kind of like people. They come in a wide range of ages and sizes. Old craters are degraded, shallow, and have craters in them that formed later. In this photograph right here, I was looking just recently. Here's some older craters. You can see they just don't pop like, say, younger craters. Younger craters look crisp. They have rays, these patterns of light that shoot out of them, and the rays are a splash pattern formed by the formation of the crater. And the two big craters on the moon that have the best rays are Copernicus right here, and that crater, by the way, is about 55 miles across, and Tycho. Tycho is right here. Tycho is in the far south of the moon, but it has by far the most dominant rays. They shoot all over the place. These rays have no elevation. They're like powder on the moon. They're best seen at full moon phase or near full moon phase. As the rays age, space weather and meteorites degrade the rays, and after about 1 billion years of age, these rays are no longer visible. Tycho, this beautiful crater, is believed to be about 110 million years old. Well, along with the beautiful craters of the moon, we have mountains on the moon. The mountains of the moon are formed by asteroid impact, usually forming the rim of a Maria. And here is the Apennine Mountains right here, the best mountain range on the moon. Earth's mountains are formed by plate tectonics and such. We don't have any of that on the moon. It's asteroid impacts. Some of these mountains tower about as tall as Earth's mountains, think Mount Everest, but again, the moon is much smaller than the Earth, so that's impressive. The astronauts found when they landed on the moon, though, that these mountains were rather rounded, not jagged. Earlier in this presentation, there was a little video of the astronauts dancing around on the moon, and if you look behind, the mountains look kind of round. They were actually the astronauts were right in this region, right at the base of these huge mountains, 16,000-foot mountains. And you'd swear looking at the picture that the shadows, they're steep and pointy, but no, after billions of years, meteors hitting the mountains basically rounded them off. If we look a little bit more advanced, a little closer at the moon, we can see something called lunar domes. Lunar domes are swellings on the moon caused by volcanic action. These are typically small, maybe 1 to 10 kilometers across, with a very shallow climb, 4% or less. They may be lacus or small shield volcanoes. And in the western half of the moon, there is an area called the Marius Hills, and there's dozens of these small shield cone volcanoes, which are domes. You can see them here. Some of them, if you look very carefully, will have a pit on the top of them like a volcano would. There is a gentleman over in Rome, Italy, Ralph Lena, he specializes in lunar domes. Like the rest of us, he's an amateur astronomer, but he's really devoted a whole lot of work to studying these domes on the moon. And Ralph Lena works with ALPO and with the British Astronomical Association. Something you'll easily see with any small telescope are wrinkle ridges. These are areas in the Maria where the lava buckles up and forms a ridge. You see one right here. The best one is the Serpentine Ridge, stretches a few hundred miles in Mare Serenitatis. Wrinkle ridges often outline the rings of a lunar basin. So you see Mare Serenity, Mare Serenity is the circular Maria here, but we see these wrinkle ridges forming another ring on the inside of that. In the Alpo, we have a person, Alberto Annunziato, who specializes in the study of wrinkle ridges. A really cool one, more of historical use than anything, is transient lunar phenomenon. These are regions of the moon that seem to change color, or outgassings are seen there. Most of them are of historic value. Dr. Anthony Cook over in Wales, he studies this lunar geologic change and compares modern views of the moon to historical observations. And what he does is, like, say in the 1800s, somebody wrote down that in this crater Aristarchus, which is the main crater we see for transient lunar phenomenon, you'll see reports in the 1800s of, say, a green outgassing on the northwest side of Aristarchus. And it was on such and such a date at such and such a time. Well, Dr. Cook gives a schedule of when Aristarchus will look like that again. We send in photographs to him, and generally we find, well, nothing's there. So he can eliminate a lot of these from the past. Turns out that a lot of them probably were due to inferior optics, vivid imaginations perhaps, atmospheric disturbances, but so far none really confirmed to have been from a gas outlet. Now, like this one, with your telescope, you can actually see lunar magnetic fields. These are called lunar swirls, which are bright areas looking kind of like lunar rays with magnetic fields associated with them. And these are theorized that magnetic fields may keep space weather from darkening this ray material. The best one on the near side of the moon is called Rainier Gamma. It's right here. I just told you about the Marius Hills, which are right up here, seen better when the Terminator is nearby. But Rainier Gamma is about 250 miles across altogether. It's made of something like ray material, meaning that there's no relief to it, it's flat. And when the Apollo astronauts flew over it, they noticed, compared to the rest of the moon, this had a strong magnetic field. The rest of the moon basically doesn't. So the idea is there's a magnetic field in this area, and it's keeping the solar radiation basically from hitting the moon. So this ray material stays protected from the sun for longer than, say, crater rays. There's a number of ideas how they formed. One of the cool ones is on the opposite side of the moon, the antipodal region. There was a large crater formed. It blew material across the moon. It collided, say, over here, and the magnetic field got twisted up in there. So kind of like looking at the sun with a hydrogen alpha telescope that you were talking about earlier, you can actually see magnetic fields, which is pretty cool. Well, why should us at, say, the Howard Astronomical League study the moon? Is there some research that we could do? Actually, there is. Starting next year, the European Space Agency is going to launch a spacecraft called LUMO, which is the Lunar Meteor Impact Observer. What it's going to do, it's going to fly to the far side of the moon to the L2 Lagrange point. So it'll be opposite the moon from Earth, okay? It's going to look at the far side of the moon for meteoroid impacts. We won't be able to see that from here in our backyard. If you remember last month, the Artemis 2 crew saw up to 6 impacts during their brief flyby of the far side. Now, in order to see the impacts, it has to be where it is nighttime on the moon, so the impacts would look like a star on the moon. Observers here on the Earth will observe the lunar night side for impacts at the same time. So we're going to be on the front side of the moon. LUMA is going to be on the back side of the moon. We're going to have a nice pro-am continuous coverage of lunar impacts for a few years. And these impacts, again, can only be seen in shadowed regions where the sun's not, okay? And all you need for this is something on the order of an 8 to 14-inch telescope, a high-speed camera like an ASA 174mm camera, which is pretty popular, and a timestamp. Basically, go out, look at the dark side of the moon. I don't like saying that, but the shaded part of the moon, take some images, see what you get. Why is this important? Well, in a few years, Artemis will build a base on the moon, and we need to have accurate ideas of how much meteoroids hit the moon for the astronauts' safety. So this work between LUMO observing the far side of the moon and amateur astronomers observing the near side of the moon will contribute both to lunar exploration and actually to lunar safety. So I hope you'll see more about this LUMO mission in the year to come and more instructions on how to contribute to it. And get out there, observe the moon. We're going to look at some guidance on equipment and observing techniques. Basically, use the optics that you have to observe the moon. I frequently use small telescopes like 60 to 80 millimeter refractors for observing the moon, as they can handle seeing conditions well. Usually when you have a refractor that small, seeing is almost always good, or else it's not worth being out there. If the seeing is good, you can push the magnification as high as you can, or even use larger aperture telescopes. All phases of the moon are good to observe. For outreach, a first quarter moon shows very nice detail along the terminator. So here we have a first quarter moon right along that terminator. Beautiful details that you will see there. Actually, the full moon is also great to observe. You can study the crater rays and the limb of the moon as well. And even at full moon, there are some shadows around the limb of the moon, especially either by the north pole of the moon or the south pole. So you want more? Imaging the moon is surprisingly easy. Use a small and usually inexpensive planetary camera and slide this into where the telescope eyepiece fits. And with some capturing software, images can be captured, stacked, and sharpened. It's kind of like magic. I know Jim Toomey is going to give us a workshop later on for ELPO about this. It's not magic, but it kind of looks like it. The moon has so many interesting features to observe. If you are not familiar with lunar topography, there's a wide range of apps, maps, and lunar atlases that you can use. At lower magnifications, study the Maria and their surface features, and at higher magnifications, study individual craters. Look at this part of the moon right here. Here's the Sea of Tranquility. Neil Armstrong and Buzz Aldrin landed right down here. Even at low power on this image, you can see various features that, gosh, what is that? Look at this. There's different colors to the Sea of Tranquility, different colors there. Up here, there's definitely a circle of different color in the Sea of Serenity, and you can see that in Mercurium as well. Well, that must be telling us that there's different features and ages about those lavas that filled in those Maria long ago. There's all sorts of resources out there for us to use to study the moon. We're going to talk a little bit about the British Astronomical Association. They have a great lunar program. We'll look at the virtual moon atlas, the Astronomical League that was mentioned earlier in the program, the Lunar Observer, my baby, and of course, HAL has all sorts of books, from what I understand, about the moon. So there's lots of resources out there. We kind of live in a golden age for amateur lunar exploration. There's a wide variety of books, atlases, maps, and apps that help us find our way of lunar discovery. And also there are 3 astronomical organizations with lunar sections. If you're interested in books for your own library or to check out from HAL, the golden book about it is Lunar Cognita by Robert Garfinkel. It's a large 3-volume set. It pretty much has everything there is to know about the moon. It's not a light read, but it has everything you need. A lighter read is The Photographic Atlas of the Moon by Robert Reeves. Perhaps the 21st Century Atlas of the Moon by Maurice Collins and Charles Wood. And Charles Wood also has The Modern Moon, A Personal Perspective. It does a great job of history and explaining the science on the moon. Great book. So here they are, the 21st Century Atlas of the Moon, spiral bound at just a paragraph here and there, tells you what you need. Robert Reeves' great book about the moon. And again, Charles Wood has a great book, The Modern Moon. There's all sorts of atlases to consider as well. Sky and Telescope magazine used to have a laminated moon map. I'm not certain if they do at the moment. This book, The Duplex Moon Atlas by Ronald Stoyan, it's laminated. It shows you a view of the lunar features, whether you're using a refractor or reflector, and it messes with the orientation. This gets it just right. And there's another book called The Atlas of the Near Side of the Moon. Here's that laminated sky or moon map from Sky and Telescope. It's pretty good. This book, The Atlas of the Near Side of the Moon, it just came out a couple months ago. It's a great book. It's well written. The problem is it's on a print-on-demand book, like so many books are these days, and the pictures are not nearly as crisp as they could be. On my phone, I have a moon globe app, shows plenty when I'm out at the telescope. And the virtual moon atlas is indispensable for use on your computer. It's loaded with all things lunar. Do get a hold of that for your computer. And this is incredible. The Lunar Reconnaissance Orbiting Spacecraft is an incredible resource. It's been orbiting the moon since 2009 and taking images of the moon. At its website, you can zoom into very small regions, graph elevation changes, look at different mineral resources, etc. It's kind of like having a spacecraft in your own hands. So we look here, we see various craters. I didn't talk about these. These are rills, which are canyons on the moon, sort of, valleys. And we look at them with the Lunar Reconnaissance Orbiter. I can put one point here, I can put another point here. So I've crossed this crater, I've crossed that rill, and look at what I have here. Here's the crater that I went through. These little dips right here are the rills right here. It's amazing. You can do this with your own computer at home. It really is like having your own spacecraft. And if you're really patient and you zoom in, you can literally see the paths that the astronauts took at the Apollo landing sites. You can see where the dust was kicked up by their boots and such. It's amazing. Before I started talking, there was talk in your meeting about the Astronomical League. The Astronomical League has observing pins for successfully viewing and documenting various astronomical features, in this case, lunar features and phenomena. The Astronomical League has the Lunar 1, Lunar 2, and Lunar Evolution observing programs. You will learn a lot by doing this, and as Jim said, you'll probably get a pin for doing it as well. A little bit of bragging rights. The British Astronomical Association has a very active lunar section. It has a monthly newsletter called the Lunar Circular that's edited by Dr. Anthony Cook over in Wales. And the BAA has lunar newsletters going back till the 1950s. So there's a lot of historical records there. That's really nice. And the Association of Lunar and Planetary Observers, ALPO, has been around since 1947, promoting the observation of solar system bodies. ALPO welcomes members of all experience levels and even has a very comprehensive training program. And look at all the stuff you can study in ALPO: solar, eclipses, remote planets, meteors, outreach, you name it, they have it all. Concerning the moon, ALPO has the following sections. We have the Lunar Geologic Change by Tony Cook over in Wales, the Lunar Meteor Impact Project by Brian Kudnick. He is in the Houston area, and you're going to be seeing more about that in the next year as the LUMOS project develops. Ralph Lena over in Rome, Italy, studies lunar domes, and I have the Lunar Topographic Studies section here. And since 2019, I've been the editor of the ALPO monthly newsletter, The Lunar Observer. It's been published monthly, well, almost monthly, since 1997. It's grown over the years. I took a look back when it started. It was a 2-page flyer, but it's certainly grown. In recent years, we've had about 80 observers from 22 countries contribute material to the Lunar Observer. The Lunar Observer is typically 80 to 100 pages per month, but some months it even approaches 200 pages. Observers contribute articles, images, and drawings of lunar features, and there is a bi-monthly Focus On article that highlights certain lunar features like specific craters, certain Maria, etc. The next one coming up in July will focus on the crater Langrenus, which is near Mare Crisium on the eastern side of the moon. Here you can see from March our contributors, and they're from all over the world: Argentina, Hungary, Belgium, Italy, USA, Bolivia, China, Hungary. We got them all. If you're in the astronomy club there at Howard, I'm sure you're familiar with cloudy nights. The Lunar Observer is featured on the home page of Cloudy Nights, and we typically get about 1,300 views per month, and occasionally we get some new contributors from this feature. So please feel free to send in your observations, images, and drawings for inclusion into the Lunar Observer. My email is there. So my question for you is, why
David, you're breaking up, I think.
Well, it's good timing.
Hey, David, are you still with us?
Is anybody still with us? To follow our end or his end?
His internet got hit by a meteor.
Hello? British Astronomical Association and ELPO.
David,
Yeah. Yes.
we lost you. We've lost your screen and you were kind of wrapping things up.
Yep. What you need me to do here?
I guess try sharing your screen again and at the
Okay.
very last slide where you were.
Yeah, let me see if I can do it again.
You had a question for us to think about, but we couldn't hear the question.
Okay, 1 second. Did you tell me where I lost you?
There you are, right there.
Okay, so we started by asking why not or why the moon. My question is, why not the moon? I hope that you see that the moon is a very interesting natural satellite of the Earth, and it's easily seen through the urban light pollution and is the showstopper at your astronomical outreach. The moon is easily observable through whatever optics that you already have. And for those of us awaiting a dark and starry sky, the moon is out there for your enjoyment. And there are a number of ways you can contribute to lunar knowledge. The Astronomical League, the British Astronomical Association, and the Association of Lunar and Planetary Observers all have lunar observing programs that have enough targets to last lifetimes. So please take the time if you're interested in contributing to the knowledge of our nearest neighbor. I'm sure Jim will share this with you in the future, but these are some resources that you can look at. And any questions? And thank you for your attention.
First of all, thank you, David. Appreciate it.
Okay, thank you.
I
you.
know one of the hot burning questions here has been about the flag on the moon. So, you say that we can't see it, and yet I think we have had some orbiters see it. Can you talk to that a little bit more in terms of why is it not visible to us, and yet some confirmation exists that the flag is there?
Yeah, obviously with your telescope that you'd use for outreach, you're not going to see it. It's too small, way too small. But the Lunar Reconnaissance Orbiter, it has flown over the 6 Apollo landing sites, and on the last 5 of them, they see the flag. It's standing. The idea is it was a red, white, and blue U.S. flag, but over these 50-some years, the sun has turned it into pure white, probably. The Apollo 11 flag was blown down when the spacecraft lifted back up. It blew the flag down. It was too close to the spacecraft. But the Lunar Reconnaissance Orbiter, check it out. They have pictures of this stuff.
Awesome. Any other questions from either in the room here or online? Well, I've got one. You mentioned early on in your presentation how it's always changing. Now, I mean, I get that it's changing, in terms of the Terminator, but, if you're saying Aristarchus had the potential for having an eruption or something years ago, it had transient lunar phenomena. So when we're at that same point in the Terminator and we don't see it, why would we keep going back looking for it?
With your solar eclipses, you have the Saros cycle of 18.6 years.
Why don't you explain that a little bit?
When the moon goes around the Earth, it kind of does precession. It wobbles around the Earth. So for the position of the Earth, moon, and sun to line up in the exact same spot, it takes 18.6 years. So like you just saw an eclipse a couple of years ago, in 18.6 years, you'll see another one on a similar path. Actually, not quite so similar. It'll be about a third the way around the Earth, but it'll be a similar path. Well, with the moon and the same idea. Every 18.6 years, everything lines up again. So the shadows of the moon that you see tonight, if you could see the moon, you won't see it again like that for more than 18 years.
Very interesting. So you kind of get a unique setup of light and shadow that
Every night.
Almost as frequently as like an eclipse. So every 18 years or so. Okay, that's good to know. Is there any particular metric that when people take a picture of a crater at that particular point that kind of says, okay, here's where we are in that particular point of that 18 years? So is there any sort of a metric that we use?
Yes. If you use the virtual moon atlas that I showed you, it'll give you an ephemeris of all the data there, and yeah, it will show you how things are lining up there.
Okay. So, and what crater have you probably studied the most? What crater is your go-to that you really enjoy?
Oh, Copernicus is so pretty. You can't go wrong looking at that. And I know some people are really good at drawing things. There's lifetimes of work that you could do there.
For sure. And like you said, it really is, you don't even really have to have a dedicated video camera to do imaging.
No.
I think you could even use your DSLR and get the adapter, and do some prime focus of the moon and get some very nice shots. I know that's how I started off with my photography.
Yep. But those planetary cameras are a lot cheaper and really easier when you get down to it.
Right, but if you have an existing DSLR,
use it.
You could potentially get an adapter and do it that way. All right.
And of course, sometimes some people put an adapter on the eyepiece so you can put your iPhone up to the eyepiece, sort of thing, and take a picture.
We're definitely seeing more and more of that. I think even at our outreach, we're seeing more people with their iPhones and they want to try to get a picture through the telescope. So that's
then they leave with a permanent thing. That's good.
Yep. Hey, Victor, you have a question?
Yes, I do. David, when you're doing outreach, I realize it changes every night, but do you have some favorite things that you like to share with folks when you're at the telescope?
You mean lunar or in general?
Yeah, lunar.
Well, obviously it depends on the phase that's there. You try to get them to see, like, if Mare Tranquility is there, you try to explain through where the astronauts may have landed, that sort of thing, so they get some understanding of that. Give them a sense of size. It's 250,000 miles away, and it's about the size of the United States. So you try to give them a sense of scale there.
Oh, thank you.
One other thing that you didn't touch on that we might want to mention is that I know that the Alpo in terms of meteor impacts on the moon and monitoring that. We've got this Lumio program coming up in about a year or so, but
Right.
they, especially during meteor showers, have had some success with people imaging the moon during a meteor shower, especially if it's like maybe half days and you can still get a fair amount of the dark side.
Sure.
So, you can consider that during the Perseids or the Leonids or the Orionids, those may be prime times if you want to try to capture some sort of a lunar impact, a meteor impact on the moon. That would be something as a resource. You could go to the Alpo and read Tony Cook's. I think is it Tony or Brian Cook? I think Brian is the one that's doing it.
Well, Brian does it, but Tony Cook is the main publicizer of it.
So that's another thing that could be of interest to our members. All right, very good. Any last call? Phil, you have a question?
Yes, hey, David, could you explain for some of the newer members who haven't recognized the telescope view when you're looking at a moon map, a lunar map, and you're trying to match them up, as well as the orientation sometimes? Could you just share with everybody on how they could get different maps and different views and and exactly what's happening? Thanks.
Yep. Oh, let's see if one second here. Can you see this?
Yes.
Yeah.
So if you're using a refractor telescope, the long skinny type telescope, basically what you're going to see is up is going to be up. So north is going to be on the top, but it's going to be flipped left and right. So you're going to be like reading the license plate backwards sort of thing. And on those moon maps that I showed you, especially that duplex book, it shows you a flipped version of the moon for that. Okay? On a reflector telescope, let's see if I can find one. On a reflector telescope, which is one of these with the mirror at the bottom, it flips the moon 180 degrees. So that north is on the bottom. So that makes it even more confusing. But again, that book gives you another map to show that. So that really.
Which book is this? Which book is this?
It's a great book. Let me be sure I can have it here. This one, the Duplex Moon Atlas. It shows a 2-page spread. One is flipped left and right for refractor telescopes and Schmidt-Cassegrain telescopes like a Celestron. And the other map, same area, is flipped 180 degrees for a reflector telescope. And it's laminated, so it's really good outside. That'd be a great one for your library if you could get it.
Is this a recent? You said this one's recent?
Yeah, a couple of years.
Okay. Yeah, we'll have to check and see if we have it. If not, maybe we'll purchase it.
I think Sky and Telescope sells it, or
I've got a question.
Yes, Steve.
So a couple of the slides you had here, like the one with the reflector, you've got some daytime pictures going on there, or just it's not dark yet. Do you have people that do any kind of daytime observing of the moon when it's up, and they're using certain kinds of filters to be able to block out some of the sky?
Yes and no. If you use infrared filter on your camera, it makes the sky a little darker. It makes a little better contrast, but it's still washed out. If you've ever looked at the moon on a blue sky, it doesn't show much, right? It shows some, but not much. I don't encourage that unless, there's something real spectacular, an asteroid hitting the moon or something like that happening. Then you gotta.
All righty. All right, David, I think that's it. Thank you again very much. Appreciate the time and effort in putting this together for us, and really appreciate the knowledge that you have given us here. So thank you.
Thank you. You're welcome, and get out there and observe. Thanks for having me.
All righty. And I will take back the control here. David, you can stop your share. All right. Wayne, you are up.
I am up. So welcome to this month's edition of What's Up in Space Headlines. Item 1 is the Transiting Exoplanet Survey Satellite TESS has a new treasure trove out. The satellite was launched in April 2018 to search for exoplanets via transit observations. So it's basically just an imaging photometer up in looking at the whole sky over the years. And in a recent paper, there was an AI-supported analysis of the first year of TESS data by Joshua Roth and all his co-authors. And they report finding 10,000 new exoplanet candidates in this reanalysis of the first year of TESS data. They looked at a set of 80 million newly developed light curves going down to stars of 16th magnitude. Previously, because of signal to noise concerns and whatever, the analysis had stopped at like 13th magnitude. And so the analysis, the light curve generation has now been being extended to 16th magnitude. And in the first year's data, they got 80 million new light, or 80 million light curves. And Roth and his team focused on the fainter stars, the ones fainter than 13 primarily, and they found 10,000 new light curves. And because this was just the first year of TESS's observations, it only covered about half the sky, suggesting there's at least another 10,000 of them waiting to be discovered on the part of the sky they haven't looked at yet. So this causes some issues because that's a lot of things to go confirm.
Cool.
Okay? This is just, hey, we think there's one here. Now somebody else has got to go and collect spectra, look for radial velocity shifts and this kind of stuff, and see if it's actually real. So that's going to be a challenge. I haven't figured that one out yet.
Cool.
But they have already confirmed one new exoplanet. Just a minute, Daniel.
Okay.
Okay. They have already confirmed one of their new candidates is a real exoplanet, and this is their light curve of it. It's not the confirmation observations. This is their discovery observation over here on the right. So basically the dots are the different data points, and the lines are the fits going through the event. And this is phased. This particular planet's best fit radius is just a little bit bigger than Jupiter, and it has a period of just over 5 days. So it's orbiting the sun every 5 days, its sun every 5 days. And so this is, if you take all the data points spread out over a whole year and you put them together and just repeat every 5 days, you get a picture that looks like this curve. This is what they call a phased light curve. Okay. So the big point of their paper was is that this is a big set of data that's hiding a lot of new exoplanets, and it also demonstrates the ability of machine learning assisted exoplanet searches. So yeah, so Daniel, you have a question?
Yeah, what's Batman model? Does that have anything from Batman?
I don't know why it's called Batman. I didn't see what they define that as. It's just what they call their model.
Looks like the bat ears right here. Huh?
Maybe that's like.
I suspect it's more this down here, the black curve.
Yeah.
It looks more like a bat ears. So I don't know why it's Batman.
Well, thank you.
They name their software something.
Could also be an acronym for, yeah, something.
Or it's an acronym or something, yeah.
Thank you.
Okay, yes.
So you said, or it mentioned that they're doing confirmatory analysis on some of those 10,000. can that be done from Earth, or does that have
Yeah,
to be done from a
It's
satellite?
typically done with Earth observatories because it's easier to get the telescope time to point at these objects or.
And it'll get that resolution? That's great.
No, what they look is they do spectra of the star.
Right,
Okay?
right. So
And
maybe
as the
I'm not
planet
using the
goes
right word.
around, the star goes back and forth, they can detect the radial velocity variations. And if they see radial velocity variations that have the same period as the exoplanet's orbit from their model fitting, they can say, yep, the star is moving, something's causing it to move like that, so it must be the planet.
Right.
Okay, so yeah, it takes big telescopes to get the spectra of these 16th magnitude stars. So, yes.
I found the Batman thing. It's an acronym, actually.
Ah, okay.
Is the Bayesian Transit Model Barrier.
Bayesian transit model.
Going back over there.
Okay.
Yeah.
Okay. So next one, got two
Would you
slides.
turn, where's your iPhone? Would you cut your Bluetooth off? Turn off your Bluetooth, your iPhone.
Somebody need to mute.
Joel, you need to move.
So Chandra has found something they're calling an X-ray dot. So the little red dots, or LRDs, have been found in deep James Webb Space Telescope images from day one, basically. And they haven't really got a good explanation for them yet because the observations are just hard to make. The most commonly accepted explanation right now is supermassive black holes that are accreting gas, and they're surrounded by dense gas cloud, basically. And so, think of a black hole surrounded by a dense gas cloud. And it's important to know it's gas because they don't see signatures of dust and X-rays don't come out. They don't see X-rays from these things. Chandra is an X-ray observatory. And so the fact that Chandra observed something that looks like a little red dot, this thing in the center of the picture there, that's actually a Hubble Space Telescope image. Okay. And then the X-ray image of the little red dot is there in the inset in the upper right. And that's the X-ray data. So it's got a lot of X-ray light coming out. And it's at a redshift of 3.28. So it's not the way distant universe, but it's pretty far away. And when you look at this object from the ground or from James Webb Space Telescope, they've observed it. It has many spectral characteristics of the little red dots that James Webb is observing. However, it has, as you can see, a lot of X-ray flux, and it's possibly variable in the X-ray, which is different from what they see with the little red dots. So they went and did some analysis of existing photometry and spectral data, mainly in the UV to the IR, to infrared, ultraviolet to infrared, and basically have shown that dust models fail to reproduce the basic, what they call the spectral energy distribution, just how the light varies with wavelength. Okay, dust models don't do it, don't explain it. So next slide. And so they're thinking that the X-ray dot may be a little red dot in transition to becoming what's a normal active galactic nucleus. Okay? A number of galaxies, a lot of the galaxies have supermassive black holes. And if you look at them, they have what they call an active galactic nucleus. It's really bright, unresolved from the ground, in particular source of light right at the nucleus of the galaxy, and it's got hydrogen emission lines and all kinds of stuff. It's active galactic nucleus. And so they're thinking that this particular object may have an intermediate optically dense gaseous envelope, not highly dense, but not transparent. And that's letting some of the X-ray light out and explaining what they see in the spectrum. So on the right, the complicated graph shows the spectrum. The black line is the spectrum of the X-ray dot, okay? The red line is the spectrum of a typical little red dot, okay? So you can see that there are some differences, particularly in this area right in here, which of course people on the screen can't see. Okay, No, to the right, a little bit right over here. Yeah, right in there. That part of the spectrum, the red line dips below the black line. So the little red dots don't quite look like the X-ray dot at that point. The blue line, which starts in the upper left and goes down, that's a quasar spectrum. And the purple line, which starts in the center right and then comes across, is that same quasar spectrum reddened by a dust model. And you can see that that does not explain the X-ray dot spectrum in the right-hand side of the plot, the longer wavelengths in the infrared. And it departs somewhat from the X-ray dot, the black line in the near ultraviolet, down around 3,000 angstroms, 0.3 microns. So this is the kind of data they're looking at. And so let's see, I kind of got lost in my flow here. So I think this object may be in a little red dot transitioning to becoming more like a normal active galactic nucleus. And since it's the only one that's been found, it's a unique laboratory to study the nature of the little red dots because we can see them in X-ray, among other things. However, we need more observations. It's the life of an astronomer, more observations, right? The old astrophotography thing, astrophotos are never finished, they're abandoned. Okay, you need more observations. And in particular, they'd like to have JWST mid-infrared imaging and spectra to see if there is hot dust emission. Okay, the longer wavelength or the shorter wavelength in the infrared, so in the like the 1 to 2 micron range, is hot dust. And so they want to see if there's any hot dust in there. Okay, so anyway, so that's Chandra's X-ray dot. And next slide. And the next thing that's coming up is the Nancy Grace Roman Space Telescope is being prepped for launch. It's the next great observatory to be developed by NASA. It's a wide field of view infrared imaging and coronagraphy telescope. The coronagraph is a technical demonstration, a technology demonstration instrument. The imaging is the primary instrument for the observatory, and it's got an imaging field of view that's about 100 times bigger than Hubble. Okay. So it is huge. They have 18 detectors instead of Hubble's 1 or 2 for their image. So instead of having to make mosaics to get a reasonable size, it'll in one image will image about the size of the full moon. So it's a very wide field. Because it's wide field and high resolution, they expect to generate about 1.4 terabytes of data every day that they have to then downlink. To give you an example, Hubble, over its entire lifetime of 36 years, has produced about 172 terabytes of data. Wow. And they're going to generate about that much every year. Right? So, but development and ground testing is complete. It's still at Goddard. They're doing the last minute closeouts. They got some thermal blankets and stuff they got to put on, but the testing is complete. It's been 8 months ahead of schedule, and it's below budget. How many times do you hear that on So they're currently preparing it for delivery to the Kennedy Space Center for a launch on a Falcon Heavy. It's going to be out at the L2 orbit. So it's going to be joining JWST and numerous other observatories. And the target launch date is now early September 2026. So that's a not earlier than date, although I heard today maybe they might move it forward a little bit, but it's not earlier than September as far as I know right now. It's more likely to slip than it is to move forward. And I think that's it for me.
Wayne, thank you. I mean, great as always. Okay, we have the SeeStar program. Basically, HAL owns a SeeStar, which we lend out to our members. Jeff, are you in the room here? Yay,
Yeah, I'm
we're
here.
finally giving you the SeeStar after 3 months. So, don't leave without taking it with you here. It's up here in the corner. So this is a really great benefit. It's only open to HAL members. You get to use the instrument for a month. I did it back in December, had an absolute blast with it. So I hope you enjoy it. Got a lot of good summer objects coming. You can maybe be spending some sleepless nights, or you can program it and just wake up in the morning and see what it did for you.
There you
So,
go.
if you are interested as a member in signing up to taking a turn, the information is on our website. And of course, we usually post our slide decks. So you would go to that URL there to sign up. Okay, so shallow skies. Mercury has very good, usually evening apparitions in the spring, late spring, and morning in the fall. So we're going to have our best apparition for Mercury in the evening coming up. Not the greatest, but still pretty good. Regardless, Mercury never strays too far from the sun, so you're going to need a good western horizon to catch it. Venus right now, you probably are picking up, it's in the west, brightest thing after sundown. It's got a gibbous phase, and it is increasing in size as we go along. I think around in July, it'll probably be at like a half phase or dichotomy, but it's definitely worth taking a quick look at that. Mars is just beginning to start its next apparition. This is not going to be a particularly great one. It doesn't come too close. It's what they call an aphelic apparition. We'll probably get into that more when it comes closer to its opposition time. But if you are a big Mars fan, it's just beginning to become visible in the pre-dawn sky. Jupiter is rapidly losing its altitude. This is pretty much its swan song for its apparition. Best thing to do is to catch it as soon as it comes out of the twilight. A lot of times the seeing is remarkably steady then, and you'll have your best height on it at that point. Saturn is coming out of the pre-dawn sky, climbing away from the glow of the sun. The rings are definitely better displayed this year. They're going to now gradually open for the next like 7 or so years. So you'll definitely have a much more impressive view this apparition coming up as opposed to last year. It'll reach opposition in October. So a variety of things to look at, nothing really, front and center, nothing at opposition right now. So here's a challenge. You can see Venus with your naked eye in the daytime. And the trick is knowing where to look and having a sky that's pretty clear. When you see these, I know you were talking about it, Jose, some of the daytime skies lately, they're this wonderful blue color. That's a good time to go try to see if you can pick out Venus out of that sky. So on this coming Monday, roughly between 4 and 5 o'clock, give it a try. Here's a challenge for you. Go out, position the sun behind a building or something so you don't have to contend with the glare from the sun. And it also helps protect your eyes, obviously. Start by trying to find the very thin, it's only a 2.5-day-old moon. It'll be very evident in the evening, but in the afternoon, it's a little harder to pick out. So see if you can find that moon in the afternoon sky. I would use binoculars first, sweep, find the moon, and then if you sweep about 5 degrees to the left and slightly below, you should be able to pick out a star, which is going to be Venus. Once you've got them in your binoculars, give it a try with your naked eye. See if you can see the moon first, and then see if you can pick up Venus. I know I've done it a few times. It's always kind of cool to be able to see Venus during the daytime. So another, and this is almost as we're up to the next meeting, so this is why I'm including this slide here. On Tuesday, June the 9th, as the twilight deepens, you're going to see Jupiter and Venus, the two brightest planets, paired together, and they're going to be pretty darn close, about 1.5 degrees apart. You also will have those two stars here. This is in Gemini, so Castor and Pollux, And Mercury will be a little bit further down, so you get almost 3. Now, Mercury, that's not much of a conjunction. That's still a pretty good distance away. But here, Venus and Jupiter, that'll be a really cool sight. Probably best with binoculars or naked eye. This is definitely, conjunctions like this to me are just beautiful naked eye things to look at. And if you have a camera, trying to grab some pictures of that. I bet you're going to be doing that, Daniel. If we have clear skies that night, you're very good at getting constellation shots. So
Have you seen the pictures I've emailed you?
I haven't seen any that you emailed me for this evening's
How did you
presentation.
see them? How did you see them?
Well, I thought that haven't you posted some?
I posted them on the house Facebook page.
Okay, so I've seen some here and there.
Didn't you see the picture of Saturn and Venus next to each other?
Yes, right.
That was back January 2025.
Yep.
What's your name?
Hmm?
What's your name?
My name's Jim Tomney.
Oh, cool.
So, but at any rate, I would encourage you guys, whether it's with binoculars or naked eye, or you want to get your camera out and try taking some shots, kind of frame some nice landscape with it or whatnot. Be well worth the effort. And now we come to our member astrophotos, sketches, and artwork. So Michael, you want to talk a little bit about I see that you're on this evening. You want to talk a little bit about your SeeStar shot here.
Sure. Thanks, Jim. So this was the Leo triplet, and I spent a good part of April in the evenings and stacked this over several nights. I think I got a little over 6 hours of resultant data, and all in the SeeStar, and did all the processing on the SeeStar. I didn't bother to do anything else with it. I thought this turned out really, really well for these 3 galaxies, and was pretty pleased with it.
Yeah, it's amazing what that little scope will do. And that is a lot of integration time. Very nice. Okay, Harini, we've got a couple of your SeeStar images here this evening. Are you on?
Yes, I'm here.
And this is very appropriate for tonight that you have a picture of the first quarter moon.
Yeah, so this is, of course, the image of the moon. And as it's written above on the image, it's the first quarter moon. And yeah.
And you can see a lot of rugged terrain along the terminator here. And there's that Sea of Crisis that David was talking about earlier, one of the well-defined Maria. Very cool. And you can actually also begin to see some rays down here. So very nice job.
Thank you.
And now this one is Bode's galaxy that you did with the SeeStar.
Yeah, so this one was originally, I was going to image process it, but then when I image processed it, it didn't really look as good as this one, so I just left it as it was. And if you could see clearly, and in the corner you can see M82 too. It's also called the Cigar Galaxy. And a few things I know about M81 is that it's 12 million light years away from Earth, and it's located in the constellation Ursa Major, and in the center of the galaxy is a supermassive black hole that is 70 million solar masses.
Wow. Very impressive. Very nicely done.
Thank you.
Okay, Bill, are you on this evening? I did put the information here. So his image of M51 here, taken with a Williams Optics Zenith Star, 73 millimeters, f5.9, and clearly doing the RGB with a mono camera here. And it was all done from the Starfront Observatory. Some of you have been to a couple meetings. I know that Chris Todd has talked to us about the Starfront Observatory. So apparently Bill has a instrument out there. Very dark skies, and as we were talking about before, last month, the whole thing about dark skies really give you a huge boost with your photography. And clearly that's evident here with this just beautiful picture of M51, the Whirlpool galaxy. So 117, I'm not going to do the math in my head. Lots of integration. And here we have Jupiter, Steve.
So, yeah, it was another night of poor to average seating for me. So I'm looking for a night that we can finally get some good seating that I can do something with. I had my 10-inch Meade out, and it was not performing well, and I've had some issues with it. So I turned to my 6-inch Celestron SCT and was able to, this is probably I'm guessing a 2-minute video that I grabbed and then processed and so forth. And got this. Luckily, I was very happy that by the time I got to using this scope and this video, the spot had come around. It took maybe it was out for about an hour and a half, and then the spot showed up, the red spot, and I was able to capture this.
Yeah, it's very nice. I mean, I really do think your seeing was fighting you very much because you shared the video with me to see, and it really was a very turbulent night. So I can tell you, Steve did a pretty amazing job here to extract this much data when the atmosphere is bubbling like that. And definitely some details here. I can just make out that there's a secondary red spot up here in the north, and he's got it there. You can't really see the edges clearly, but it's there, as well as some other features. So good effort, especially with a 6-inch.
Thanks.
Got a question for Steve. Can we see the red spot with a 5 inches aperture telescope?
Can we see what?
Can we see the red spot, the great red spot with the telescope?
Can you see the red spot with
Okay, 5 inches telescope.
I'm not hearing
Yeah,
anything.
5 inches.
So if you-
inches.
Average telescope.
What, 5 inch?
I mean, you.
Can you see with a 5 inch?
Yeah, I don't know.
So visually, yes, you should be able to see it with a 5-inch telescope. Certainly with photography, absolutely, you would be able to record it with a 5-inch telescope. You've got to have, obviously, it's got to be near the central meridian for your best chance to see it. Sky and Telescope will tell you the times when it's due to transit. The other thing is if you happen to have a filter, a blue filter, like a Ratten blue filter, and they're usually, I take that back. They used to not be expensive when Orion was around, but since they went out of business, I don't know what the prices are now. But a blue filter will generate better contrast because red is an opposite color of blue and it will darken it. So if you, and it's all about with planets, it's primarily visually, it's a game about contrast. Can you get enough contrast to detect the object? So yes, I am sure with a 5-inch, you could definitely catch the great red spot. You might need a night of good seeing. You probably want it close to the central meridian. And then once you see it, you'll probably be able to pick it up much more easily the next time around. Your brain and your eye, the whole pattern, it's kind of like playing a musical instrument. You get better and better at doing it. So,
You recommended a green filter for me?
a green filter will do the same thing as a blue filter, yes.
So I got that green filter, and after getting the green filter, I was able to see the 2 bands.
Okay.
The 2 bands that we see, I was able to see, and which I have never been able to see before. And thanks to you, and after getting that filter, I was able to see the bands, but I was never able to see the red spot. So that's why I asked him if I can see that too. I have never spotted the red spot so far.
Well, I'm going to take it as an action item to get a list of, over the next month, good opportunities for seeing the red spot certain times.
Okay.
We're going to get you to see that red spot.
Thank you. You got me to see the bands.
We're halfway there then.
I noticed that
But
when
you're
I'm
losing it in the
I know, but
sky, so.
we got a few more weeks yet. We're going to get it in.
But once you see, it is difficult to unsee. So.
Yes.
Yeah.
I have been seeing that now. As you said, it plays a trick on your brain.
Absolutely. There
It
is
takes a while
definitely,
to see the bands.
yeah, I really liken it to playing a musical instrument or something. You have to practice and you get much better at that.
But thanks, Jim.
You're welcome.
I noticed that when I had the Mead out, that's my 10-inch one, that I'm having some issues with attaining like perfect focus. I also noticed I had very little contrast to the eyepiece, same eyepiece or whatever I was using. It was just too bright. And then when I moved it over to this 6-inch, I could see details. I could see that there was a spot. I could actually see some of the banding, and I just could not see that. I'm not sure why. That's troubleshooting I need to do, I guess, with the bead.
I think sometimes with a 10-inch, again, the brightness, you
It's
almost
also
have to
an
let your,
f6.3 scope versus an f10 scope.
yeah, you
So-
almost have to let the retina, I mean, when I'm doing visual with my 10-inch, I always use some sort of a filter.
Okay.
Always.
That
I
might
have
be
a
good.
variable polarizing filter that you can.
Another
use
great
to-
choice. Yep,
That might be.
Yeah.
that would be a great
So
choice.
something like that on the, mine's just a little 80 mm, but like when I'm looking at the full moon, it's like impossible. So put that on there and crank it way down, then all of a sudden you can see detail.
Yep. All right. Very good discussion. Thanks, Steve. Jose, this beautiful picture. Tell us.
Yeah, second time I take a picture of the sun. I'm so surprised that this was what I got on the second time. I'm still debating whether on the right middle side, that's what is it? Coronal mass ejection, CME on the right, outside of the sun.
Oh, out here?
That thing over there,
that's
if
not-
it is an artifact of the telescope, I don't know.
That's a heck of a CME if it's
Yeah,
that far
that's
away
what
from
I
the
thought that
sun.
maybe it was something on the telescope, on the imaging train.
Well,
Hey,
Jose, sometimes,
Yeah,
Jose,
Bill.
sometimes you see, I've witnessed the filaments breaking off and floating away. I've actually been able to watch them visually, and that they could literally be the filament could be so thin that you don't see it, for lack of a better way to say it, attached to the sun. But sometimes they just drift off, and that's probably what that is.
Yeah, I tried not to stretch it too much just to get that, because I didn't want to blow the rest of the sun. It was like pretty bright. But and I took this with the Coronado PST I got the beginning of the year. It's been fantastic to be using that on monochrome. Actually, this picture I took with a color camera, because I was trying to show people with color. I figured that they were going to find it boring, black and white.
Black and white. Yeah.
And that was a color camera, and I got pretty good contrast and pretty good.
No,
Yeah, you did a really good job, Jose. You were able to get it from the artistic event side. You didn't get really hard edges there, so it looks more natural, and you got the detail. And there's always a hot spot that gets frustrating, but you can't do anything about that. And you did a good job of minimizing that. So I think it's a great shot.
I remember you gave me advice on that last time, so thank you. I appreciate it.
Oh, you're welcome. The bill's in the mail.
All right, Wes, you need to take center stage here. You are the winner of the object of the month, the Leo triplet. Nicely done. Want to tell us a little bit about what went into this effort?
Yeah, so let's see, about 188 frames that says what? 90. About an hour and a half.
Yeah.
On this. Took it from my backyard. Is probably my first truly successful, deep sky picture. So yeah, I just just one night processed it in PixInsight and just played around with some of the different techniques that I've been, gleaning from YouTube tutorials and stuff like that. Yeah, but just got it, get tracked really well for the whole time, all that kind of stuff. So I'm the more I use it, the more I'm impressed by that 585 sensor. It's just very sensitive and can pull in good light in relatively short exposures.
Is that a cooled camera?
Yeah.
Very nice.
Yeah, so I think I probably had it at like -20.
And I
That's
love the
square center,
details.
right?
No, that's the 533. The
The
585 is 4K 16:9. Yeah.
Well done. And
So this is the comet that we had recently, the C2025 R3 Pan-STARRS. I was out near Gettysburg and had what was forecasted to be a clear morning, and then the closer I got to the morning, forecasted deteriorated a little bit, but I still got up at like 4:30 to go check it out. So it was definitely cloudy. So when I tried to process it, normally you do a star extraction. So you do a star alignment and extract the stars so that the stars don't get all streaky. But that just left little like black dots all over the place because of the clouds. So all that vertical banding is from all the clouds from the stacking. So I just stacked it, and the streaky stars give it some movement, which is kind of neat. But I pulled that from my S30 Pro, which was nice because it meant I could just say, go to the comet, and it went.
yeah, very nice. Definitely some detail there.
Yeah.
And one more.
Yep, this is Markarian's chain. So I get annoyed that the SeeStar always gives me like these vertical pictures, so I rotated it. And so the Markarian's chain starts like toward the upper right-hand side and then curves around down the left. But it's just a dense area of galaxies. And so basically everything in this picture that's kind of fuzzy is a galaxy. And there's some of them on the left side that are like fairly defined with spiral arms, and others are just fuzzy spots. But there's a lot of galaxies in this photo.
Very nice.
It's Virgo cluster.
Yeah.
Wayne.
This is my M81, which is I guess the May object of the month.
Oh, April.
April object of the month, excuse me, thank you. This was over 3 nights in April, thank you. It's about 13 hours of exposure time in LRGB with a monochrome camera from Alpha Ridge Park.
Nice.
Very nice. Great detail. I love this. Is this like a little
Yeah, that's
irregular
a satellite
galaxy?
It's a lot like, say, the Small Magellanic Cloud.
Right.
Its catalog is Holmberg 9.
It's gorgeous.
What's your focal length there?
1600 millimeters.
Okay.
It's a 8-inch f8, 200 millimeter f8, so about 1600 millimeters.
Very nice. When they're applauding for you.
That is that is most of the field of view of the telescope.
And that is going to be a wrap. Again, my thanks to David for his presentation tonight and for all of you coming out, and great discussion here this evening. We do have our next planning meeting on June the 1st. Again, you're free to drop by and see how the sausage is made, or maybe participate. Maybe you have some ideas about what you'd like to see us do. We'd love to hear from you. And then the next meeting is June the 11th. I believe that we're having a talk about an instrument that is potentially going to be on the sent to the moon, HARP 2. I wish Mike was on. I have to double check with the presenter, but it's a scientist at UMBC who's going to be giving the talk next month. So again, thank you all very much for coming, and I will look forward to seeing you next month.